NASA's Solar Dynamics Observatory, which watches the sun constantly, captured an image of the event. A recent solar flare unleashed a massive plasma plume from the sun's south pole, where these stellar eruptions rarely happen. The unusual phenomenon is a sign of the impending solar maximum. A gigantic plume of plasma recently exploded from the sun's south pole, where solar eruptions almost never occur. The explosion, which a photographer captured in stunning detail, is another telltale sign that the sun is about to enter its most active phase, the solar maximum. The rare phenomenon occurred on February 17th, when a solar flare exploded from a sunspot near the sun's south pole, releasing a gigantic column of ionized gas, or plasma, that towered around 124,300 miles, 200,000 kilometers, above the solar surface, around 15 times taller than Earth, spaceweather.com reported. The plasma eventually snapped away from the sun and hurtled into space as a gigantic cloud, known as a coronal mass ejection, CME. Astrophotographer Eduardo Schaberger Popo captured a highly detailed composite image of the plume before it broke away from the solar surface. The plasma column was so large, I had to rotate the camera to fit it into the frame, Popo told spaceweather.com. It was truly a wonderful spectacle. This stellar blast was extremely unusual because it erupted from the sun's south pole. Most solar flares erupt from sunspots on or around the sun's equator and almost never from near the magnetic poles. Because the poles are where the sun's magnetic field is strongest, which normally suppresses sunspot formation. Due to the orientation of the flare, the CME was directed away from Earth and the rest of the planets, which all orbit the sun on the same plane. The unusual eruption was likely triggered by what scientists call a polar crown filament, PCF, a loop of magnetism that circles the sun's magnetic poles, according to spaceweather.com. The plasma plume that was spat out by the flare is known as a polar crown prominence, PCP. PCPs become more common during the solar maximum, the most active phase of the sun's roughly 11-year solar cycle. During this phase, PCF shrink in size, like a tightening noose around their respective poles, spaceweather.com reported. As these magnetic crowns constrict, they strangle the nearby magnetic fields, making them more likely to explode. NASA's Solar Dynamics Observatory, SDO, is a mission launched in February 2010 as part of the Living with a Star, LWS, program. The objective of SDO is to understand the sun's influence on Earth and near-Earth space by studying the solar atmosphere on small scales of space and time and in many wavelengths simultaneously. SDO aims to learn more about the sun's magnetic field and how it is generated and structured, how the stored magnetic energy is converted and released into the heliosphere and geospace in the form of solar wind, energetic particles, and variations in the solar irradiance. SDO is equipped with a suite of instruments, including the Atmospheric Imaging Assembly AIA, which captures high-definition images of the solar atmosphere in multiple wavelengths, the Helioseismic and Magnetic Imager HMI, which studies the solar magnetic field and the physics of the solar interior, and the Extreme Ultraviolet Variability Experiment EVE, which measures the sun's ultraviolet output. This comprehensive set of tools allows SDO to provide unprecedented insights into the workings of our closest star, facilitating a deeper understanding of the solar processes that affect our planet and technological systems. Experts believe the solar maximum will arrive at some point in the next few months, earlier than originally predicted. As we approach solar maximum, more and more weird phenomena are occurring at the sun's poles. In February 2023, a PCP broke off from the sun and got caught in a PCF, creating a swirling plasma vortex that raged around the sun's north pole for 8 hours. And in March last year, a PCP collapsed in on itself, creating a gigantic plasma waterfall near the sun's south pole, which was shortly followed by an enormous plume of rotating plasma, known as a solar tornado, near the solar north pole that lasted for 3 days.